So we were discussing about the basic data types of Python, right? So if you are familiar with other programming languages, I have already told you that this is the basic building blocks. So how you interact with your program and how you code your program, everything is depending on uh, the way that you interact with the basic data types, right? So we discussed about different data types, and and last week what we did was we discussed about tuples, right? So we discussed about tuples, and we identify the unique uh, characteristic of tuples or the attributes. So main one is the immutability. You may remember. So we discussed about those, right? So before we are moving to the next part, I would like you to uh, try to refresh your memories. So there's a small quiz here. So shall we do it? You can answer. Uh, you can answer through the chat, right? So what do you think about the answer to the question one? What is your what is your answer? If you can remember, what is the answer? Somebody can type in. So the answer to this one is actually this is a false statement, right? Because the tuples in Python do not have a lot of methods associated with them. Last time when we checked, you remember only two methods are associated, right? Indexing and retrieving. So that's all. So this is actually a false statement. So if you go to the next one, next question. So it says tuples are immutable, right? Whether is it true or false? And somebody answer. Is it a true or false statement? Yeah, tuples are immutable, right? Tuples immutable means once you prepare the or once you inserted the elements to a tuple, so it is not possible to change it. So this one is true. Tuples are immutable, right? The correct answer. Okay. So finally, what is a tuple? How you define it? How you define the data type? So which one of these is a tuple? Can somebody send that answer? Is first one is a tuple, the second one, third one, or none of the above is true? Which one is the answer that you think? Can somebody reply? So let make this session interactive, right? Otherwise, it will be boring to you and boring to me as well. So please, if somebody can answer, you can send your answers through message, or you can talk, no problem. So which of the following is a tuple? The construction. Okay, I'll explain then. So the first one is actually a list, right? This is a list type. This is how we define a list using a square bracket, right? And the third one is actually this is an error. We don't have any definition for this particular data type. So this is not the answer. So actually the answer is this one, right? So you may remember that we construct a tuple using parentheses, right? So parenthesis is the construction element of a tuple. So we have used that tuple, and when we were discussing, I told you a tuple can have different kind of data types within itself, right? So that is what has happened here. Is everything is a tuple. So first element is an integer, second element is also an integer, and final element is a list. This list has two elements. That's a different story, but this whole segment is a tuple, right? So uh, that is what's the answer here for the question 3. So please refresh your memories regarding those data types that we discussed about, because those are very important and we'll be interacting with them often, right? Then we have final two data types to discuss, right? That is, one is sets, right? So set means that it is a unique set of elements, that is collection of unique set of elements. So that means that elements inside a set do not repeat, right? So we'll see some examples and you will understand. So that means there's only one representation is available inside that set, right? There's no repetitions. So this is also an important data type, right? So when it comes to sets, when it comes to other data types as well, we have to also talk about the booleans, right? So I think you have come across with these boolean data types with other programming languages as well, right? Definitely. So boolean means true or false, right? There's no middle ground. So output is 1 or 0. That means 1 means true, obviously, and 0 is false, right? So this is a binary data type, we say, and it's very important to have this data type when we are dealing with what we are calling control flows. We are going to discuss about the control flows in short moment, and when we are building logics, right? So let us go back to the uh, Python examples. Let me share my example sets. So if I hope that you are now familiar with at least a little bit uh, with Jupyter notebooks, right? It's very good and interactive method to learn the Python language. So let me share my uh, Jupyter node respective Jupyter notebook so you can see it and we can interact, right? Okay. So sets and booleans. So I have prepared this. Sorry. So I have prepared these examples for the both set of data types, right? So as I told you, sets are actually unordered collection of unique elements, right? So unordered means there's no order, but the elements inside that set is unique, right? That means only one representation of each element is available, right? So to do that, we are using actually a function called set, right? So uh, the uniqueness of this one is that you can define a variable which is belongs to this particular set function, right? So that variable contains elements that are unique, right? So let me show you, right? So here you can type with me if you have open up your Jupyter notebooks. Please try these things. So I'm creating a variable called x, right? And I'm making it as a set type variable, right? So let me run this one. You can run using this run button, right? And do you remember I told you last time you can access to associated methods using dot and tab, right? So can you see that this x is now a set type variable, right? So it has say various number of methods that you can interact with, right? So these are the methods in that is associated with this x variable, right? Okay, so I'm using a method called add. So that means I'm adding elements to that particular variable, right? So I'm adding one. So here I will run this line, and then if I check, it will show that one is there, right? So of course this output shows the element within two curly brackets, right? So you may remember that we are associated these curly brackets with dictionaries, right? Dictionaries have key value pairs, and you can create dictionary using curly brackets. That's what we discussed. But the thing is that this is not a dictionary. This is a way of representing this object. So because this particular uh, element does not have a key and separately a value, this is not considered as a dictionary, right? This is considered a set type, or it's actually representing what's inside this variable, right? Okay, so let me add, let me clear these outputs for it. So run this. So now we have one, and let me add a different element, right? So so now two unique elements are available, right? So you may remember when we are adding objects, or when we are adding elements to lists and tuple, sorry, tuples we cannot add. When we are adding elements to lists, there is no limitation, right? You can add same type of data or equal data as much as possible. So it doesn't filter out any, uh, I mean, if there are uh, duplicate items inside lists, it will not filter them out, right? So, but in this case, let's see what will happen if I try to add one, right? So see, so one and two now available. If I try to add one again, see, it will not add anything. But if I try to add three again, right? If I try to add three, so it will update, right? So if I try to add three once again, it will not update. So it's accepting only unique elements uh, to the variable, right? So that is what I wanted to show you. So even how many time I try to add existing element to the this set type variable, it will not accept, right? So another advantage of this one, right? So we can of course create sets by adding elements, right? So there's another option. You can take existing one and you can filter out any duplicates there. So as an example, so here the list have been created with different types of integer numbers, right? So there's 1, 2, 3, 4, 5, and 6, 7, 8, and the ones and twos are they are repeated. They are repeated elements, right? So if I create this one, and if I feed this particular list and consider it as a set or feed, right? Look what happens, right? So I'm feeding it to the set function, and I'm reassigning this value to a different list, right? If I run this, if I hit it, it has filtered out all the duplicates, right? So this is the output that we are getting from the above operation. So that is a advantage, right? And also, uh, I encourage you to check all the methods associated with set data type. But like previous sequence and unordered type of data, you can access the elements using indexing. So what I have done here is that, so I'm accessing the sorry third index position, right? So see, it will give an error, right? So that means even though it's a date, I told you it's unordered, right? So it looks like that we can access these things using indexing, but this is an unordered type of data. So you don't have any order there. We are getting this one because it is how we are feeding the data there, right? So main things that you have to remember or to understand when you are dealing with sets type of data is that it contains unique elements, right? And they are unordered, and you can create a set type data from scratch, or you can use existing data set like this, and you can feed it and get unique elements out of it, right? So that is the background of set type of data. Okay. So any questions from that part? Do you have any concerns? If you have any concerns or questions that you need to clarify before we are moving to the next part, you can ask now. Okay, so seems like no questions. I just try to interact with those. Uh, I mean, snippets, code snippets. And if you don't understand, please ask me, or you can send me a message or email anytime. So I will share my thoughts about that, right? So let's move on to the next part. That means Boolean type of data, right? So I think you have interacted with this type of data before. Similar, so no difference. So Boolean means there's only two uh, types of outputs available. That means true, which is sorry, uh, true, which is corresponds to integer 1, and false, which is corresponds to integer 0, right? So there's also a placeholder available called none. That means until we have a definite result, we can keep or reserve that variable, right? So it's, I mean, we are calling in programming it's placeholder, right? So that placeholder value of which is called none is also there. We'll see some examples, so we'll get to know or get to understand what I'm talking about, right? So Boolean has only two outputs, is true or false, which is you can map to ones and zeros, right? So Here I am creating an object with Boolean data type, right? So A is equal to false, right? Which is Boolean. So if I check the type of that particular variable, it will output as Boolean, right? So we can assign Boolean variables, of course, as we wish, right? So we are going to discuss about these comparison operators right after the end of this section. So any logics, if there's any logic associated with our program, definitely the output will be Boolean, right? So if you check this particular line of code, so one is bigger than two, that means it is actually false. So output of this code line will be false, right? If I run this one, so it will output as false set one. Okay, so as I told you before, if we have not assigned any value to this variable, so we can keep it as a non-type variable, right? Which is uh, we have not decided whether it's true or false, right? It's just space, has space, so that we can assign sort of a data type, right? Okay, so let me show what will, as an example, what we can do. So here, so I have not decided yet. This p is true or false yet, so I can keep it as none data type. If I print, so it will print as none. See, and this type it will show as a none type. It's not boolean yet, but we can keep that variable aside, so we can use it later, right? So that option is also there. Okay, so any problems with that Boolean data types? I actually think it's quite simple, especially because you are ICT students and you may have come across this type of data previously as well. So if you have any questions, this is the time to ask about this particular. Okay, so let me let me go to the next section. So we are now moving uh, where we can use different kind of comparison operators to construct a line of code, right? So let me share the screen. Um, Comparison operators. Okay, right. So Python comparison operators. So these operators actually uh, allow us to, as name suggests itself, so comparison operators allow us to compare variables, so values, right, and get an output as a Boolean value. That is what happens comparison operators, right? So these are like very straightforward operations, and you are and often used with basic mathematics, right? So I mean, mathematically, I think have uh, all of you are familiar with this comparison operators, but when it comes to programming, there are some slight differences, but basics are still the same. So let us check what are these operators, right? So for the purpose of explanation, I have prepared a small table, and let us assume that a variable a is equal to 3 and variable is equal to 4. So both of them are integers, right? So there are actually main 6 variable operators, right? So this one is what we call assigning, assigning operator. So this is actually not true operator, and this one is larger than, this is smaller than, and this is larger than or equal, and this is smaller than or equal signs, right? So we can check the outputs of each of these operators, right? So first one checks whether left hand side means this one is equal to the right hand side, right? So keep in mind, if we use something like this, this is a sign, right? This is a sign, and this is comparison, right? So only one equal sign means assigning, two equal signs means we are comparing the left hand side and right hand side. So that is the basic that you need to keep in mind, right? So the first one that we are discussing about this equal sign or comparing sign, right? So what is output? This is actually not true because a is actually equal to 3, b is actually equal to 4. That means we are actually checking whether uh, yeah, we are actually checking whether 3 is equal to 4, right? Which is not true, right? So second one is not equal to, right? So this is checking whether left hand side is not equal to right hand side. So of course 3 is not equal to 4, right? So this is correct statement, that means this output is true, and this is larger than, we are comparing whether the left hand side, that means 3 is larger than 4, right? So this is actually statement that is not true. So output will come as false or 0. The third one, sorry, fourth one is smaller than left side. Whether we are checking left hand side is smaller than the right hand side means we are checking it whether 3 is, sorry, whether, yeah, whether 3 is smaller than 4, right? So 3 is more than 4. This is actually the truth statement. And finally, final two, we are checking whether the left hand side is larger than or equal to 4, right? So this is also not true. So not true, not valid statement. And finally, smaller than or equal. That means we are checking left hand side, which is 3, is sorry, smaller than or equal to 4, right? So this is a truth statement. So that those are the basic 6 comparison operators that we are dealing with, right? Okay. So let's see some examples in Python environment. So you can, as always, do these examples with me. Okay, comparison operators. Okay. So so this is the table we just discussed, right? So I will share these notes with you. I will upload these to the LMS. But this is what actually we just discussed, right? So the 6 comparison operators that we are dealing with. So let's walk through which is through these comparison operators with a quick example. So this is left hand side is 2 and right hand side is 2. We are checking the equality, whether left hand side is equal to right hand side if you run. So it's true, right? And here also we are checking the equality. The left hand side is 1, right hand side is 0. Of course, it is a false statement, so you are getting definitive answers, true or false, right? So I don't know, it may be answers like that doesn't come up in Boolean data types, right? Or when you are doing comparison operators. So the answers are definitive. So not only numbers, that means integers and floats, you can actually check strings as well, right? So when I was starting the lecture, I told you, of course, there are programming languages. Of course, we write the programming languages which is slightly similar to the language that we use day to day, and close to English, right? But when it comes to the computer, everything is a number, right? So here, yeah, of course, it says hello, right? Of course, it says hello, but this is actually a number to the computer. So this, yeah, actually, this is a string type, but it contains some value. So we are checking the two values here. So you can check the text. See, it will output as false, right? So because of course the left hand side text is different from the right hand side. Another thing is that what do you think the output of this particular line will be? What is your guess? What will be the output? Whether this will be the output true? Can you answer? Somebody and send it through the chat box. What do you think? Is the answer is true or false? What is your guess? Can somebody tell? For this particular statement, line of code, what would be the output? Hmm? So actually, the output is false. Right? Of course, the same set of characters are there, right? I mean, same word is there, by, and here is also by. But the first segment, the word has a capital B, whereas this right hand side, the word has a simple B, right? So capital B is a different statement, simple B is a different statement. So it carries two different numbers, right? So think about it. So it actually is a false statement. Okay, so yeah, so we discuss about this particular line, and the next one is identical. So the left hand side is identical to right hand side, which will come out as a true statement. So equal signs, equal comparison statement. You can use both integer and string type of data, right? To check whether to not to check, I mean to compare whether both sides are in the same set of data, right? Okay, this next one is not equal. So this is actually a flip of the equal sign. So this one, first statement will come as true because we are checking whether the left hand side is not equal to right hand side, which is true, right? And the second line is, of course, the left hand side is equal to right hand side. So that means it is true in that sense, but we are checking whether it is not equal to, right? So yes, it is not equal to, it is equal to left hand side, right, left hand side and right hand side are equal, but when it comes to not equal operator, this is actually false statements because these are equal, right? So not equal statement become false, right? So there's slight kind of a gimmick there. So if it is not equal, it is true. So if it is equal, then the output is false, right? So be aware of that when you are using this kind of operator, right? Next is also the simple lines. So greater than or equal, the first one is actually true statement. Second one is what? False, false statement, right? So true false, you can obtain like that, right? So then less than sign. So this first one is true statement. The second one is actually a false statement. Like that, you can get the results. And finally, final two. So larger than or equal. This one is actually true. Second one is larger, so not equal. This is come to the false category. And finally, less than or equal. This one is actually true, and this one is actually false, right? So I think now we have covered these basics of comparison operators, which is very useful when you are constructing your program, right? When you are designing your program. So we have covered that part. So finally, I want to check or show you how you can use Now we are checking only one. We are checking only one. What do you call statement here, right? So we can use chain comparison operators, check multiple logics. Okay. Okay, I think this part is pretty simple. So I will move to the next one, which is chain comparison operators. So chain comparison operators means that you can combine two or more statements or the or conditions, right? So have you heard about an O and an O? I think you should. Even in other languages also, this one is pretty common, right? So can you see here? Here, instead of only two elements, we are checking about uh, we are comparing three elements, right? So here we are checking whether one is smaller than 2, and in the second line we are checking whether 2 is smaller than 3, right? So the complete statement is actually true, of course, right? We can rewrite, I mean, for clarity, and in this way we cannot use O type of logic, but for clarity we can separate this one using an and statement, right? So if I run this, you will get the same result. You will get the same result. So it's still checking whether one is smaller than 2 and 2 is smaller than 3. Right? This is what we are checking. So to check, it should not be in the order. Right? So here we are checking. So 1 is larger than 3 and whether 3 is larger than 2. Right? So if I run, I will get the results. Of course, 3 is larger than 1 and 3 is larger than 2. This final output is true, right? We can use AND statement and we can combine these to get more clarity to what we are writing here, right? So if we run this statement also, we will get the same result as the output, right? So we can also use the O statement. So that means only one of the logics need to be true to proceed, right? So here's an example. So we are checking whether one is equal to 2, which is not true, and also we are checking 2 is smaller than 3, right? Which is this part is true, right? So even though this first one is not true, at least one of the conditions of the statement is true, right? So we are combining it as O logic. That means we'll get 2 as the output, right? 2 as the output. So you can use this and then O to fuse two logical operations according to your requirement when you are constructing your code, right? So Let me try this one again. So here I'm checking one is equal to one. This one is actually true, or 100 is equal to one. So which is not true here, but at least one of the statements are true here. So if you run this one, you will still get true as the Boolean output. So what I want to explain here is that you can, if you have more than one comparison need to be done before you are proceeding to the next stage of your code, so that can be done. So directly you can use a chain like this, but it's clearer and more what do you call, presentable if you have, if you are using these kind of and or statements construct this chain of comparison operators, right? So with that, we conclude this the section two, section of comparison operators. So next, what we are going to do is, sorry. Then next, what we are going to do is to discuss statements, right? So introduction to Python statements. So before that, do you have any questions regarding what we have done so far? Any concerns, any clarifications need to be done? Do you need what kind of feedback do you have regarding the things that we did so far? Okay, so based on what we have discussed so far, next week I will give an in-class test, right? So with the help of Prabhat, we'll do a small test. So I want to check whether we have done the, I mean, the explanation that we discussed have got have gotten into you. So I'm going to give a small class test next week. Next week, okay? Based on what we have discussed until now, until comparison operators, right? Okay, pass the message if somebody's absent here, right? Okay. So shall we move on to the next part then? If you don't have any clarifications need to be done. So we have to discuss this Python statements, right? So using actually Python statements, now you're actually learning how to construct a set of codes. Statements are required to construct codes in Python. So let's start with the control flows. That means if else statements. I think this is very common way of controlling how the program responds, and definitely you have uh, learned about these if else statements which or control flows in other programming languages as well, right? So uh, for the sake of completing the discussion, I'll small roughly go through. I mean, lightly go through it, right? So as you know, so if we want to check a condition, right? So at that stage, we will be using these control flows, right? So right. So as an example, this is a slight example. So if I have a dog, and if my dog is hungry, so that is the condition. So if the dog is hungry, then I can feed the dog. So this is the action. So there should be a condition to identify or to control the flow of chain or flow of line. So next, according to the requirement, so you can take an action, right? So definitely there's a condition. If the condition is there and if the condition is met, then you will take an action. That is what the control statement means, right? So to the control for the control logic, we have three keywords. The first one is if, right? Second one is if elif. So this is similar to else if actually in other programming languages. So the keyword here we use elif, and finally else, right? So unlike other programming languages, these control for syntax or the construction, we use colons, right? And indentation. Have you heard about indentation before? I think you have, right? Indentation is actually how much white space that we are leaving out to make our text understandable aesthetically, right? So by looking at it. So this indentation is the key feature that we are using in Python to understand, I mean, give information which is the dominant process, which process comes after that, right? So this is how we control the priority of the coding lines, right? So the indentation system or the indentation method is very crucial to Python, right? If you miss the indentation, then your program may not run properly, right? And that is also the key feature that makes Python apart from the other languages. So we'll discuss uh, when we are doing the examples. So other languages they use semicolons, curly brackets, square brackets, different kind of syntax notations or special uh, symbols to inform that there's the end of line, there's the start of control for start of loop like that. So there's different kind of special characters are used, but instead of that, Python just use white space, which is indentation. So you can arrange your uh, code very clearly and you still get the same output, right? So this is the syntax of if else statement. So the first type. So if this is the condition that we are making. So your condition can be given here and you have to terminate that using colons, right? So your statement need to be, sorry. So your statement need to be, yeah, here. So your statement need to be terminated using a colon and after that colon you can execute some kind of a code. So this is actually code, right? And then see that there's a indentation here. So if and then the else they are in the same line and there's a small indentation afterwards to show that so this is the dominant one and this one comes after next. So the control of these statements in Python are done using the indentation. So keep that one in your mind, right? So this is if and then you can check the else, right? So else also you have the colon. So you can terminate with the colon and there's a indentation here as well to show that this particular line is inside this else statement, right? That is done using the indentation, right? So this is the construction of so if else statement, right? So it has only two options, if and else. So you can have multiple options as well. So multiple condition, multiple control flows. So that is also a possibility, right? Depending on the requirement of your program. So when it comes to that, you have to use if, elif, and else statement, right? So similar to previous one, the if and else, so they have this colon, and you can introduce a third or a fourth or a fifth condition, some other condition to check, right? So it also defined in the same way. So if else, so the other condition, and keep the indentation. So it comes under this if else statement, and this one comes under this if statement, and this one comes under this statement. That means if you check the condition, else if you are checking the other condition, you can go as much as you like according to your requirement. And if your condition does not match to any of it, and finally you are choosing, okay, then it doesn't go, or it doesn't fit with any conditions that I'm checking with, the final one will be selected. So that is the construction of a if else control for statement, right? Okay, so let's take some examples. Let me go to my codes. Okay, so yeah, so this is the same kind of a construction here, right? So this is a from another language. This is actually how you write in C. I think you have followed C language and you can understand. So this is how we represent the same thing in Python. So try to spot if there's similarities, and if differences. Try to note what are the differences and similarities Okay, so I think you have spotted some differences. So the main things I will show you. So the Python has to remove these curly brackets, right? So curly brackets has been removed. So usually in the other languages, these uh, curly brackets are used to enclose something in a statement, right? So this in this if statement, these lines are enclosed, right? So that's why these curly brackets have been used. So Python has removed those curly brackets. And also, this is an optional thing. That if you need any kind of clarity, you can keep parentheses, but still you can work without those things, right? Here also you can see this parentheses are not there. You can have it if you like, right? But these curly brackets you don't need. If you write the same statement with curly bracket, it will result in an error, with an error, right? And also, the end of line. So these are two 40 lines, right? So the end of line is terminated by semicolons, right? So this is a common practice in other languages, but in Python that is also not there. So if you end the line and if you go to the second line, that means the end of it, right? There's also we have used white spaces. So two different line means two different commands, right? In other languages, you can have this line at the same level, it will still work, right? But it will be a little bit cluttered. It's not easy to understand or not easy to read. So that can be avoided and has been avoided in this Python. See that semicolon also missing. So everything has been arranged to provide this particular indentation, right? So the if statement, we line by the line and we give the condition and we terminate that that line only. So showing that we are using inbuilt uh, Python statement, right? So we use colon and we terminate it, and then we have to keep this white space. So this will allow the writer or the coder to enclose uh, the process which is comes after the conditional statement, right? So another thing that you have to remember is that these two lines, those two lines need to be in the same level. So as you can see, it's in the same level, right? So this is the basic method of constructing a Python statement using indentation, right? As I told you before, indentation is very important in Python, right? So let me show you another example. So here, right, this is kind of a if else statement, right? So we will check if this X condition is met, and if it is met, we go inside and we will check this Y condition is met. If both of these conditions are met, then we will run our code, right? And if this is not met, that is, if this is false, and it will go to the other statement, right? So we can do the same thing using indentation. See, we are lining up accordingly. So according to the indentation that we keep, it decides which line comes first, which line comes second, which lines are enclosed in a particular control flow statement, right? So you what you have to remember what you have to remember is that Python is heavily dependent on this indentation and white space, right? Of course, it is the advantage is it is readable and it is less cluttered, right? But The coder need to have a clear idea of keeping this indentation when it comes to Python coding. Do you have any questions regarding that? Any things that you need to get clarifications? Right. So let's use these concepts and we'll start to code. So here I have used pseudo codes. That means these codes do not actually this code may run, but let's interact with same using the same concept but with actual codes. So you will understand what we are talking about. Right? So if you have any questions, you can ask now. Let me share the screen. Okay. So we will discuss about the basically if statement, if else statement, and if else statements. That means we have several types of flow control statements, right? Okay. So this is the structure of a basic if else function, right? So as you can see, this is the first set of condition lines. They are in the same alignment. So that means these are belong to same if else statement, right? And the action that you want to perform, right, it is in the kind of slightly right indented. So this giving us the impression that this action is actually inside this if statement, and this action is inside this else if statement, and finally action 3 is inside this else statement. So that is how the construction goes, right? So let's do some examples, right? Okay. So as I told you before, as we check, you can create a boolean variable like this, right? Okay. If you have your if you have your laptops and Euclid notebook installed, try to find what is the answer of this one. It's very simple output. Can you check? You can do the coding and check. Right? So what happened is that if at this level, it is checking whether the condition is true or false. Right? So we have already assigned this variable as true. So after the, after confirming that it is true, you come inside and will print this value. So if I run this one, so it will output as equals true. So it will come until here, right? So you can check with the same example, adding some logic here. So let me check. Let me reassign a variable x with a false value. So now it variable x is false, right? So code line has constructed in this manner. So if this variable is true, then it will print x was true, right? Else, so in that, and now we know that it, of course, it exists. not true. That means it's false. So it will not go inside here, but it will come to this else statement, right? And it will come to the else level, and it will print this paragraph, right? So what actually happens is that it will not go inside here. So it will not go inside this one, right? There's no chance of going inside here, but it will come here because X is actually a false statement, right? So if I run, output will be, yeah, we printed in this case where X is not true, right? So we have single branch, uh, two branches, that means if else, and with the introduction of if else part, you can have multiple branches, right? So this is an example of this multiple branch operation, right? So if you like, you can try this one. Try and see what will happen. You can change the location and you can check what are the outputs. Please try and see, try this small coding and snippet and see what is the output is. If you have any questions, you can ask as well. Try this part of the code. This is branch if elif else statement. Right. So what happens is here. So I have created a variable which is called LOC. That means refers to the location, right? So it refers to the location, and then I have a if else statement which has multiple condition points, right? So in the first one, it is check whether the person is in auto shop, right? And in the second condition, it's check whether the location is back, and finally checks the location is of the if the location is university, and finally if none of this is satisfied, it will give and ask you, it will print and ask you where this particular person is, right? Because it doesn't match with the uh, initial variable that we have assigned, right? Okay, so I will run the program and you can see the output. If you have already typed and checked, so it's good. So otherwise, you can still try. So here, location is what I have said is bank, right? So it will print out the second line. okay, we have there was a problem here. The power went out. So let me share my screen again. Please let me know if you cannot hear properly or if you cannot see the screen properly. Okay. So we were discussing. So it was statement right here. So yeah, we were discussing this example. So yeah, so currently this variable holds a value called bank. So because it holds that value, it will go inside this condition. But we can change, right? We can change and see what will be the output. See? So if I run this one, see, so it will print this one, right? So this condition is get satisfied, and it will print the value inside that particular statement. So say I will type something like home. So it doesn't go inside any of this. Uh, it doesn't agree with any of these statements, right? The first statement it doesn't satisfy. Second, third, or uh, all these three conditions are not satisfied. So because of that, if I run this one, the program will ask, actually, where are you? Right? Because it doesn't satisfy the condition. So that is how you construct this if, else if, and else. So else if means else statements, right? So those are control flow statements. So we'll check another example, right? So this is a kind of a greeting system. So we are constructing that the greeting system here. So if the person is Sammy, so we'll print it as welcome Sammy, and if not, it will ask what is your name, right? So now this variable holds that value. Because of that, it will print welcome Sammy, right? Print, if I provide a different name, it will ask what's your name, right? So simple as that, right? So we can elaborate this one. So means we can introduce different options as well. So here now it has two different options to check uh, which person is interacting with the program, right? So initially, if I inserted the person's name as Joe, and if I run this one, I will output the last. It's only satisfy the last condition, right? So it says, "Welcome. What's your name?" So instead of that, if I put insert George, same thing, and it will say, "Welcome, George," right? Which is in agree with our construction, right? So until now, uh, we interacted with uh, strings, right? But it doesn't have to be string all the time. Can be any condition which you like, which you want to check whether true or false, right? When we are doing small exercises, so you will come across with these different types of conditions that we want to check in these control flows, right? Okay, so basically, this is the construction. We discussed this one. If something is true, then it will go inside that. If something is false, it will go to the next stage, right? And we can check that if the true or false in the same line as it is indicated here. So with these several examples, so I think you basically have a good idea about what we are talking about the control flows. So please let me know if you have any questions before we are going to the next section. Okay, so again, before going to the next one, I want to stress the importance of indentation, right? So please have a good understanding how this indentation works, right? You can refer books and there are a lot of materials in internet regarding these things. So indentation is very important. So if you do not keep an indentation properly, and say if you have wrongly kept the indentation, it will result in an error over the output. Sometimes, even though you have given indentation incorrectly, there will be an output. The output is not correct, right? So, the calculation outputs and things like that, it would be affected if you do not keep this indentation. So, I'm stressing out here, indentation is very important, right? So, let let's do some quizzes before we go into the next part. So the next part is actually loops, right? So we have to discuss about loops. I think in other programming languages you may have encountered with this type of control statements, right? There are two types of loops, for loops and while loops. We are going to discuss those things for the sake of the completion, right? I think you are aware of it, but bear with me. So let's do some exercises before we move on to that. Let me share screen. Okay. Um, I cannot I cannot find that file. So let's continue to the next part. So we are discussing control statements, and the next control statement that I want to introduce is loops, right? So loops. Okay. So there are mainly two types of loops we are dealing with, right? So one is for loop, another one is while loop. So for loops are used for iterations. Iteration means that you are repeating something some number of times. So that is iteration means, right? So we can iterate over each element in the object as we prefer. So the objects like lists, they have several elements, right? It can be one or two elements or several thousands of elements. So these elements are this you can iterate through these elements using for loops, right? So during the iteration, right, you can execute set of commands or set of processes, right? It depends on your requirement, right? So as an example, so if you have a string, we can iterate over each character, right? So we can create a program. It will go or iterate through every character and print character separately, right? Or we can iterate over a list. So as I told you, this can have, like, this can have several items like this, right? So we can go through each and every element if we want, and we can print it out or automate as we like, right? Similar thing happens with the dictionaries as well. So it depends on your requirement, right? So let me show you the syntax. So more or less same as other programming languages. So here, what you have to keep in mind is indentation is important. I'm stressing it out again. So here you have a list, right? This is the list, and there's the for loop. So in this small snippet, what happened is that it will go through each and every item, and it will print, right? That is what happening here. So this particular variable can be anything, any variable you like, but you have to provide a variable in this first line to temporarily assign what you extract from your original object, right? This can be a number, it can be a name, a string, it can be another set of lists. It doesn't matter, but you have to temporarily assign this element to a variable, right? And to run it. So check. Check how it happens. So my irritable is the variable which contains uh, a list, and in that my iterable, you take out one by one. You take out one by one and assigning it to a variable, and you will print them out. So that is basic syntax uh, for the for loop. Sorry, and your output is also comes out like this accordingly, right? So it's pretty simple. So most of you have interacted with these kind of loops in other programming languages as well. So let me open up my Python notebook and let's do some examples, right? Okay. So after I share these documents, you can check these notes. So it's basically what we discussed up to now, right? So this is the general form of for in Python, right? So you have for keyword an item. This item can be anything, any variable that you like. Please, don't use any assigned variables in Python, but other than that, you can use a suitable variable name there. And the object means, so we have objects, that means list, tuples, things like that. So those are the objects. Inside that object, you have items. So you extract that item, and you will do whatever the uh, thing that you want to do, you want to process, right? So let's do some examples. So for loops can be used to process different kind of data. So it can interact with any type of Python 8-bit data objects, right? So we'll just start a simple thing. So this is a list, right? So we can print this one by one, right? So what you can do is you can there's an option to extract this element one by one from the list and to print it out. But kind of you can automate it using a for loop, right? You can take out all these elements inside that for loop using a inside that list using a for loop, right? So this is what we are going to do. So for this is number, this is a variable that I choose in list one. So this is the list one. So we are printing the number, right? So let me run this one first and comes to this one. So what will happen is until this set of elements are over, the for loop will run. So see, so it will print the elements inside one by one, right? And I think you can understand what happens here, right? So let's couple this one with the if statement. So to elaborate a little bit and to understand how these control flows interact with each other. So before that, I want to introduce something called modulo. Are you familiar with uh, this modular function? Are you familiar with this modulo? Right. At the first set of lectures, I explained this. Right. Under mathematical terms that we can use for Python, we discussed this part. You remember? So modular means modulo checks the remainder, right? So if I divide this 17 by 5, the remainder is actually 2. 2. Okay, of course, up to 15 you have 5's multiplication, but after that, to 17 you don't have, the remainder is 2, right? So this makes sense, right? So this one also we can check, right? Tens, uh, so multiplication of 3's to 10 is actually 1, right? Up to 9 you have multiplications of 3, but for 10 you don't have, so the remainder is 1, right? So this is also the same, right? But the important thing is you can use this specific modulo function to check whether a number is an odd number or an even number, right? So this check actually comes more often in programming than you think, right? So it's direct uh, access to check whether it's a number we are dealing with is an odd number or even number. So if I run this one, this is 0, right? This is even number, of course, right? No remainder. So if I type 5, so always 1 is remaining. So if if I divide a number by 2 and it gives one remainder, that means it's a odd number. But if no remainder is given, right, like this, then this is an even number. So we can check odd even numbers using this simple method. So we are going to utilize that one. In the second example, we will be using the same list, right? So instead of printing every number, we can now choose to print only even numbers from that list, right? So we check each number one by one using the for loop. So that is what happened here, right? And after each number is extracted, it will feed through this control for statement, which is if statement, right? If the number modulo, moduled by 2 and if the remaining is 0, definitely it's a even number, right? So we are printing on even number here. Else, there's no else here, but if it is not divided, I mean, if it is not even, we are letting it go. Only the even number can be, uh, in this particular statement, only even numbers are, right, will be printed. See? Okay. So we can also introduce a else statement additionally. So instead of doing nothing, we can print it's a odd number in the output, right? So it will come like odd number 2, odd number 3, something like that, right? So see, and check the output. See, so odd number 2, odd number 4, odd number 6, like that. You can check the output. So is this example 2 is clear to you? Okay, I hope that that part is clear to you. So try to do, okay, so this is something that for loop can do again. So try to do this set of example. Try to build this code and run this example and see what will happen. So what we are doing here is we are calculating sorry, connection was not stable. Okay. Okay. So try to check with the check the output with this code. What's the output? What we are doing is we are checking the sum of all the elements available in the particular list, right? So try this example. So you can let me know if you need any support or anything, right? Please please check whether this code snippet works without giving any errors. Right. Okay. So let's check. Okay. So first of all, we have to define a variable which need to be uh, which we need to store the sum, total sum, and then we can loop, right? So for the same loop, right? We are using same type of loop to iterate through all the numbers, and we'll extract the number, right? Extract the number from here, and we'll be adding that number to original number. So as an example, so first number one will be added to 0 because initially the value is 0, right? And it will go back in the loop to the top, right? And the second one is number 2. So number 2 will come. So number 1, the initial number is now number 1. So number 1 will be added with number 2, right? And the value will be updated again. So now this underscore sum is 3, right? So I think how you can understand how it works. So we'll be extracting one by one, and we'll add it to the variable that we assigned previously, and we'll update that variable, this summation, and go until all the elements inside the loops are added to the final sum. So if I run this one, okay, if I run this one, say it will print what will happen one by one. So initially 1, 3, 6, 10. Likewise, at the end, you will get all the numbers, right? And I think I have mentioned this one before as well. So instead of, if you are reassigning or you are updating the existing uh, variable periodically, you can do the one way, you can do this one. The other way is is a small simple way to do it. So plus equal number can be used. So that will also do the same operation. It will get the number, add it to the and update the current value, right? So this will also result in the same output, right? See, so instead of printing all the values, now it will print only one value without any problem, right? Right. So okay, so let's go for the example for the next example. So now we work with numbers and lists with for loops. Now we can. I want to show you whether we can use strings with for loops as well, right? So it's also a possibility. So it's also a possibility you can use for loops with for loops with strings as well. So here, what we are doing is we'll be extracting uh, letters from this paragraph. We can one by one extract letters from the paragraph and we can print that letter uh, as we wish, right? So it depends on our requirement, of course. So we can print or do some other operation depending on what we need. So here just to provide you an example how it works, I will do this. So if I run this one, see that it will print all the letters one by one, right? Print all the letters one by one, and the interaction is correct, right? We have extracted letters using a for loop. Okay, so that's that. So the next one, so we work with uh, list and we work with what you call string, and this is an example that we can work with tuples as well. So I have defined a tuple here. So exactly same construction. So we have to define a variable and variable in the tuple, that's tut, right? And we extract one by one from here, and we are going to print it as well. So if I run this one, it will come up with the same results. So the tuples is also fine, it's more or less acting same as this, right? Finally, this type of a list, right? So can you see this example? We have a list, but inside that list, we have tuples, right? So we can directly, you know, take out tuples as it is. So next, as an example, if I run this one, and if I run this line, yeah, it will give you outputs as one set of numbers is one element, right? So this one set of tuple is one element. So this will print similarly as the previous Sorry, there was an internet problem. So yeah, uh, let's go back to the discussion. So yeah, so this one will be given, or it will be take as an output as a whole, right? So for say that for some requirement, you'll be needing this as separate output. Like instead of 2 comma 4, you need 2, 4, 6, 8, 10, 12, 12 like that, right? So we can do it by just defining the variable similar to the construction of the tuple that we have inside, right? So see what we have done here. So 4, that is standard. So here instead of using single variable, we have used the same construction variable type, right? In list 2. So parenthesis t1 comma t2, right? In parenthesis, this is in the same construction as the top one, right? And you can print each of these elements separately, right? The previously both of them came as one because of course it is considered as one element. But in this method, in this particular method, you can take all the elements out as separate outputs, right? So if you run this one, right? See, now it's giving you individual numbers, right? So this is what you call tuple unpacking. So it's an easy way that you can extract uh, tuple data using a for loop, right? Indexing is one thing, but this one is also another method of accessing or uh, unpacking the tuples. As we discussed previously, tuples are immutable, so you have to unpack it or you have to extract the values. So if you want to manipulate the values inside, so this is one method of doing that, right? Okay. So now we discussed about until tuples. So finally, we will discuss about dictionary data type with focus, right? So if you use dictionary data types, so this is an example, right? So this dictionary has three keys and three values corresponding to that specific key. So if I run this one, so it will only print the key value, right? So that is how the dictionaries are designed. As I told you, when we were discussing, we are accessing the values through keys, right? That's what happened. So of course, then it will provide only the key values inside that particular dictionary if we use hold, right? So for cases like this, right? So we can use inbuilt methods. So do you remember that we uh, discussed about dictionary methods like keys, values, items, right? So in items, it will show all the items. If you use key method, it will show all the keys, and value method, it will show all the values, right? So you can access. I'm repeating again. So so you can access. So you can access to your uh, methods or the methods using dot tab, right? So you have typed the value, then dot and tab, and you will get access to the methods associated with that particular object, right? So this is a method associated with this dictionary object. So if I run this one, it will show all the items with the keys. right? So if we want to print keys and values separately, see, we just have to provide this structure, right? So k comma v structure is key and value structure in d dot items, right? So it will provide separately which are the keys and which are the values, like this. This is the key, this is the value, key value, like that, right? So this is how we interact with uh, different data objects uh, and for loops in Python, right? So finally, I want to explain while loops, and after concluding that one, we'll stop for today. So let us finish the last part, while loops, and conclude. So let me share the screen. Okay, right. So while loops. So in this loop, why do we have two separate set of loops, right? Like for and while. Why can't we have only one if we are going through the same iterations? The main difference is for for loops we are providing a sequence, right? It will go one by one or one after the other, right? Until that provided sequence is end. Right? Say that we can with for loops we can say for 1 to 100 do something, right? So it will repeat 100 times. So that's what happened. We cannot define a condition there, right? So for that purpose, we need while loops. So in while loops, we can define a condition, like if x is larger than 2, run the same operation again and again, right? For example, so if say if I have a pool, right? So if my pool is not full, so keep filling the water with pool. Yeah, pool with water, right? Will be keep filling water until the pool is full, right? Or if we go to the same example that we used previously, if the dogs are hungry, keep feeding the dog, like that. So while some kind of a condition is satisfied, the loop will be continued. Whereas the for loop is set of iterations that will go sequentially, right? It's a sequence. So this is a condition, right? So those that is the main difference between while loop and the for loop, right? So let me show you the construction of the while loop, right? So this one is slightly similar to if else as well, right? So while some Boolean condition, so that means true or false condition need to be provided, is true, right? Then you are doing something. If that is true only, then you are looping over and over again. You are repeating it again and again. Else, right? You can do something different. Okay, so that is how it works. The while loop. works, right? So let's check with some examples. Right? So let's take some examples and you can conclude after this. Right? So as we discussed, this is the basic format, so the general format. So you are testing a boolean operation whether it is true or false, and if it is true then you are running some set of command, and if it's false you are running different kind of statements, right? So this while until this while statement is true you are repeating the same set of codes, right? So as an example, so this is here. So initially I have defined x as 0. So while the x is less than 5, so it will print the value of x, and it will say that x is still less than 5, and we'll add 1 to x. So in this inside the loop we are adding 1 to the original value, right? So this will go up until 4, and when it comes to 5, so then the 5 is less than 5, which is not true, right? So we will get the pin from 0 to 4, as you may see. So 0 to 4 we will get result, right? So it's less than 5 and adding 1 to x, and at the end of the loop, so 5 is less than 5 means false. It will not go inside the loop, and it will break the loop and come outside to the main code line, and will print the while loop has ended, right? So see that it is keep going until the statement understand that while loop is false. That means the true condition breaks, right? So we can add an else condition here as well. So like the previous method. So here the x is initially 0. So while x less than 5, we are going through the loop printing values, and if everything is completed, and we can print all is done. So else is introduced there, right? So if I run this one, we will get the similar result. Let's see, we will get the similar result, right? Okay, so that is the basic of for and while loops. So I think it's simple enough. You can understand it without a problem. Yeah, as you may have come across with these kind of structures in other programming languages as well, right? So before concluding, I would like to introduce three key aspects in looping. So one is break, second one is continue, and finally is pass. So these are very important when it comes to avoid any infinite loops, right? There are something called infinite loops, and if you stuck in that, you will never going to come out, and it will affect your programming power as well. So yes, it's very important to have these break, continue, pass statements appropriately in your coding, right? So this break means, sorry. So the break means, sorry. Yeah, yeah. So yeah, this break means it will break out from the current process enclosing loop, right? So it will not continue. It will break out. Or the even the loop is not completed, it will come out, right? So continue means it will go top of the process enclosing loop. I will explain. And final pass means is kind of a placeholder, right? It will do nothing, but it will keep the loop in the main code, because if you do not provide any statement, it will raise a error, right? To avoid that, the pass keyword can be used, right? So let me show you an example, right? So see, we are taking the same example. So initially there's a value, right? We are printing the same thing again and again. So if s x is equal to 3, there's a different statement. Else we'll be printing something called continuing, and we will continue to the process enclosed loop, right? So this is the process enclosed loop is this one while, and it will keep printing, right? So if I run this one, see 0, and it's not 3, so it will come to here and print continuing, and you will go back again to the process loop, right? 2, 3, and when it's 3, it's printing differently, right? And 4, it will go to the process enclosing loop likewise. So we can use this continue function or continuous keyword to go back to the processed enclosing loop, right? That is the purpose of that one, right? Then let's check what will happen if I put break. So break, so at x is equal 3, this whole loop will break. So otherwise it should print until 10, right? So this is to understand it easy more clearly. I have put something under the main code, so saying this is the main body of the code. So after breaking after breaking this loop, it will come back to the main code. If I run this one, see, it will go until 3, only 3. After 3, it will break out, or it will break the loop, right? So that is what you do with the break keyword. So continue keyword, it will continue the loop. Then by going to the process enclosing loop. Break means it will break the process enclosing loop and will come out from the iteration. Finally, pass. Right? Pass means we don't do anything. So if it's kind of a placeholder actually. So it will hold that place of the loop without damaging the structure of it. Right? So if I run this one, see, so it will do anything. It won't do anything. It's just come back to the next statement, right? It won't go back to the loop, but it will come back to the next statement, right? So see what will happen if I delete this one, right? So there's nothing there. Oh, sorry. So if there's nothing here, so if there's nothing here, right, I will get an error because we must provide a statement, right? It is a must to provide a statement. So that's why we need to have something called pass there, right? Okay. So there's infinite loop as well. So I will not run this one, right? So there's no coming out from this loop, right? These kind of functions are used in embedded systems, which is you need to run same thing again and again, which you call the super loop. That is a different story, but be careful not to run this kind of while loops, because if it is always true, the loop will be infinite. It will run until the power is there, right? So that is about uh, break, continue, and pass. So you have any questions regarding that before we conclude the lecture? Okay, so as I told you before, we will have a small in-class test next time. So please bring your laptops and be ready. You can upload. I have not decided how to conduct it yet, but mostly we will be doing it on your laptops, and you will upload the results to the LMS. Okay, so be ready and ask your friends. Be ready as well, right? So if you have any questions, you can anytime you can reach me through the emails, or uh, ask your demonstrator and lecturers to contact me. I'm happy to clarify any doubts that you have. Okay, so thank you.